Exercise 1J. So let's recap again. When it comes to simultaneous equations, it is when two straight lines are drawn, how many possibilities of intersection can you expect? Yes, Sean? There's only one possible intersection, okay? And the answer is there are technically, yes, there's only one possibility, but there's only one intersection, but there are three possibilities here. Unique solutions when they intersect once, so you have one intersection. Zero solutions when it's parallel, and infinite solutions is when it's exactly the same line, okay? Now, remember, at the point of intersection of two lines, both lines share the same, very good, same x and y coordinates. Now, let's have a look again. So, we know we're finding the point of intersection between two straight lines. Your textbooks will rearrange the linear equation to look like this, okay? And when it's in this form, in your year 9, year 10 level, use elimination because it's quicker and easier. And then I'll show you why they leave it in this format, okay? With substitution, what you'll likely do is you rearrange them, okay? You rearrange them to get y equals 4 minus x, and this one would be, y is equal to 5x minus 14, right? Instead of doing that, that takes one extra step. So elimination method likes it if you keep the x's together, so x plus y equals 4. And then the other one is 5x minus y is equal to 14. They call this equation 1, and they call that equation 2. Now, how the method works, so I'm showing you the how, I'm not telling you the why. How the method works is the first thing you look for is, because you're either eliminating the x's or you're eliminating the y's. And the way to eliminate it is you need to make sure the quantity is the same. Doesn't matter about the sign, just matters about the quantity. So when I say quantity, the x's on the top here, equation 1 has only one x. The bottom has 5 of these x's. They're different quantities. Whereas the next one, this one has one y, and I know it's positive 1. And this one is also 1y, but it's negative 1. It doesn't matter about the signs. These two have the same quantities. When they have the same quantities, you can either add or subtract them to try to eliminate it. Now, if you think about it, I've got a positive 1y and a negative 1y. Do I add or subtract these two to make it 0? You add them. Okay, so in this scenario here, I would say, well, the best scenario is if I want to use elimination method, I'm going to add them. And so how we add them by columns. That's why they like it in that format. Okay, so x's with x's, y's with y's, and then numbers with numbers. What you get is x plus 5x is 6x, y plus a negative y is 0, 0 of those y's, and then 4 plus 14 is 18. And therefore you get 6x is equal to 18. And solving for x, divide both sides by 6 because that's times 6 there. That gives you 3. So I'm just going to write the method here. I'm dividing both sides by 6, by 6. And that's how we get x equals 3. So that is the x coordinate of your turning point. How do you then find the y coordinate? Not turning point, the point of intersection. Joanne? Yeah, because remember the point of intersection, we said both the x and y coordinates are the same. If x is 3, the y coordinate's the same as well. So it doesn't matter which x you sub in. X can go into this one or x can go into equation 2. Which one's easier? I'd say equation 1 because it's only x plus y equals 4. So I would sub it back into equation 1. So sub x equals 3 into equation 1. What do I get? I'll get then 3 plus y is equal to 4, and logically you can already see y must be 1. Or you can subtract 3 on both sides, and you get y equals 1. So the point of intersection is 3, 1. This, for a lot of students, saves a lot of time because there's less substitution. You literally get the first one by elimination. Now, the method works because I said the quantities had to be the same. What happens if you get an equation where they're not the same? So for example, what's this? Logic. I'll talk about the logic soon. What about this one? So this is on the other side of the page. 4y plus 3x equals 15 versus y minus 2x equals 1. So keep the x's in the same column, keep the y's in the same column, keep the numbers in the same column. The problem now is there's 4y's, 1y, 3x, 2x's. They're not the same. Elimination method works when they have the same quantity. So what do? Anyone have an idea? Rah. Yeah, because it's an equation. You can double it, triple it. You just need to find the lowest common multiple of the two numbers so that they end up having the same value. So in this case, you choose which one you want to make equal. To me, I would do the y just because I can see I just need to times that by 4 and then the rest by 4. Rather than if I had to change the x's, I have to times this equation by 2. Then I have to times this equation by 3. That's 2 steps. I don't like doing too many steps. I like it one clean, simple step. So I would prefer, if this was equation 1, equation 2, instead of trying to make the x's the same, you'd have to times both equations by the 3 or 2. Whereas this one, if I just said times this by 4, then I times them all by 4 to get the y quantities the same. Then my new equation 2 now looks like this. I'm going to do a star for it. So new equation 2 now looks like this. 4y minus 8x is equal to 4. This one, compared with equation 1, they both have now the same y quantity. Get that? Okay, so if you focus on it, I'll highlight it for you. Equation 1, equation 2, they both now have the same quantity of y's. By using elimination method, do I add equation 1 and 2 or do I subtract equation 1 and 2? What do? Subtract. Okay, so you can choose which one you want to do. You can do the new equation 2, take away equation 1, or you can do new equation 1, take away new equation 2. It's up to you. All right, so here I would probably do 1 take away this one because 15 take away 4 is a nice one. So I would say do equation 1, take away equation 2. So what does that look like? I'll just write it again so it's clear. You have 4y plus 3x equals 15. The other one now is 4y minus 8x is equal to 4. If I'm going to subtract them, this is 0. 3 take away a negative 8 is positive 11x. And then 15 take away 4 is 11. Dividing both sides by 11, that tells me x must equal to 1. Okay? So that's elimination method compared to substitution. There's less rearrangement. You get right to the point, column by column. As long as the quantities are the same, you can add or subtract to get rid of them. Later on, when you do indices in the year 11 methods, we have exponentials and logs. You can times or divide. In this case, it's add or subtract. Yeah. No, doesn't matter. As long as you eliminate one of them. Because the whole idea of elimination method is to reduce 2 unknowns down to 1 unknown. Once you have 1 unknown, it's easier to solve. Okay, so now that you know x, you can sub it back in. So it doesn't matter which one you sub back in. You can sub x back into the first one or x into the second one. It's up to you to be able to solve. So if I subbed it back in, I'm just going to say sub x equals 1 into, maybe I'll just do number 1. So that becomes 4y plus 3 times 1 equals 15. 4y is equal to 3 equals 15. Sorry, plus 3 equals 15. 4y is equal to 12. Take away 3 on both sides. And then y is equal to 3 if you divide both sides by 4. So I'm moving a bit faster because I'm assuming that you already know how to solve that bit. If you don't, let me know. That's inverse operations there. So that tells me point of intersection is at 1, 3 for those two lines. What I'm more interested in is not the method, because the method you guys will learn and then you'll memorize it. What I'm more interested in is, does anyone know why we can just add the columns or subtract the columns? Why didn't I just times the columns? Why is it that I can do 4y plus y, or take away y, and then 3x plus or take away 2x? Why is that? Why does the elimination method work? Does anyone have a clue? was just curious whether anyone mentioned it to you. Oh, good. I'll show you how cool it is, okay? It's a very simple idea. It goes back to year 7. So, here's the logic. Go back to the previous page. Here's the logic. So I gave you this equation before. I said x plus y equals 4 and 5x minus y equals 14. So I just wrote it again here, right? Here's the logic. You know how we, when we balance equations, let's just look at the first one here. When we balance equations, if I told you to do this, if I told you to add 4 on one side, what must you do? Add 4 on the other side, right? So we know that balancing equation back in year 7, whatever you do to one side, you got to do to the other. True? So that means you can add or subtract whatever you want. There's nothing wrong with that. I can add a 4 to one side, and that would make this 8. But then here, if I add a 4, it'll end up being x plus y plus 4. True? But here's a little tip. Adding that 4, so I'm going to change the color so that we can see. Adding that 4, doesn't 4 also equal x plus y? You see that? So that 4, you're saying 4 is equal to x plus y based on the equation. 4 is the same thing as x plus y, so why can't I replace that 4 and write it as x plus y? And this is the beauty part, because you said before you knew if I did plus a y to it, the y and the negative y will cancel out. So they said, oh, well in that case, why don't I just say, in this scenario, this is my equation 2. I want these two to add. Where does this come from? This comes from adding 4. So here I can say, oh yeah, let's add 4 to one side. Let's add 4 to the left side. But if you add 4 on the left side, that is the same thing as writing 5x minus y plus 4 equals 18. But that plus 4 is the same as x plus y. There's nothing wrong there. So if I write x plus y down, instead of this 4, this is why when you collect like terms, you've got 5x minus y plus the x plus the y equal to 18. And what you end up doing is 5x plus x, which is the column. That's what you were doing. See, if I zoom out, that's what you were doing there. X plus 5x is what I'm doing here. That plus y minus y, well, there's my plus y minus y. Right here, plus y minus y. And why did I do 4 plus 14? Well, because I just said add 4, add 4. That's it. It's just the definition of what 4 represents. And right at the start, they already told you. 4 is equivalent to x plus y. And so I just replaced that 4 with x plus y. That's why these two cancel out. But why did I add a 4? Is because I knew positive y and negative y will cancel out. That's why it's okay. Okay, and that's why you write in columns. But if I taught you guys this is more confusing, because this is a substitution. It's me taking this and substitution it in. That's why they call this elimination method, because it reduces that thinking. You just do it methodically. You do it without thinking, but there's a theory behind it. The theory was very simple. It's just the idea of balancing equations. If you add 4 on one side, you can add 4 on the other. But that 4 came from here, which is why the quantities need to be the same first. You want to make sure there's a quantity that eventually will cancel out. Whatever you add on one side, you can add on the other. Simple? All right, so that might take a while to sort of get if that didn't make sense to you there, but that's the theory. That's today's lesson. That's it. And so again, you've got today's lesson and Friday's lesson to learn both skills. Eventually, you can just choose one. Doesn't matter which skill, elimination or substitution, both of them solve for the intersection. So you just need to know both eventually. Okay? Or you can do what I did, just stick to one method all the way.